today's topic is going to be about wiring harness. I'll just be giving a brief introduction to wiring harness for all of you guys. Okay, so to start with, we'll have understanding about wiring harness introduction. We'll have some terminologies being looked into. We'll understand about how the wiring harness process flow happens, okay, in industries, correct? And then what are the suppliers for automotive wiring harness components generally, and what are the standards we generally follow for wiring harness applications, correct? And then some other key aspects, and also basically about software too. Okay, and then further we'll try to have your questionnaires also. Okay, so let's start. Okay, so what is basically a wiring harness? Is the term basically wiring harness is referring to something which is an assembly of components what you see here in this image. Okay, so basically wires, connectors, terminals, protective coverings, right, or insulations generally, or the clips and clamps for mounting them, the fuses and relay boxes which you can see in your household also, similar kind of things, right? Retention devices basically for mounting the components, okay, or providing additional support and protection. Then further guiding channels and other electronic components. Okay, a combination of all these things are generally basically called as a wiring harness. Okay, so what you generally see in a household, we generally call the wiring systems, okay, or wiring. But coming to the automotive industry as such, we generally call it as the wiring harness, correct? So this topic is basically, or this area is one area where an engineer who works within an automotive industry for understanding how the layout can be so that all the connections between different systems in a vehicle can be done. So where rather it be the lighting system, your infotainment system, and all other things, correct? So they need power as well as signal, correct? So so that's what we are going to look forward to and how it works out, correct? So starting with the wires, okay, the wire is basically basically bundles okay, of metal wires, okay, or metal components which are kept together. Okay, basically, as I was mentioning, it was or the main functionality of wires is basically to carry the current as well as the signals. Okay, so it can be with respect to the different systems to be connected together, the engine area, the lighting systems, different meters as you can see in your console, okay, the navigation systems, okay, the GPS systems, okay, your power windows and doors, okay, and then other systems which you can see, okay, or the n number of systems which you can see as a part of your vehicle, correct? So these wires are made out of metals, okay, so these are made out of conducting materials, okay, so copper are one material which you can generally see, or it can be material like zinc, etc. Okay, so and they will be having insulations provided accordingly to make sure that it is having protection. Okay, so that's what wires are generally termed or defined accordingly. Correct. Now, another main component which forms a part of your wiring harness is basically your connectors. Okay, so these electrical connectors are electromechanical devices. Okay, why electromechanical devices? Because it's basically having the functionality for carrying the current as well as the data, okay, or the information to be passed on. And then the material is being covered by plastic. Okay, it's having a plastic housing so that it can be protected from the environmental conditions, correct? So these are basically for making the connections. Okay, so there are multiple parts which forms a part of your connector. It can be the overall outer structure which we generally call the housings. Inside you can see the terminals where the wires will be connected to. Okay, and then there is something called as wedge locks, basically for additional protection or to make sure that the connectors when connected in connected positions, okay, they are fixed properly. There can be seals for protection from wind, the dust entry, correct, as well as water entry, correct, and then mounting clamps, etc., for additional locking purposes, correct. So a connector is basically electromechanical devices for making the electrical terminations, correct. So basically made out of plastics material for the outer casing, and internally you will be having the electrical connections for the connectivity. Okay, so this is what a connector is going to look into, correct. So further we have terminals. Okay, these has the similar functionalities as what we have for the connectors, but connectors basically are used for long sets of wires, correct. So for terminals are for one particular functionality. Okay, so They are again used for termination, correct? So there are different types which you can see. It can be a o-ring type. Okay, so the one which you see here is an o-ring type. Okay, and then you can see the open tongue type. Okay, and then further you have the different others. So you can see for small speaker units and other things, you must have seen these kind of wire units, correct? With the terminations or the endings basically made out of these kind of materials, correct? So these are basically used in the wiring harness application as well as yeah, in automotives. Okay, so these are basically called terminals. Okay, these are again made out of metal. These components are also, you can see the different color variations. Okay, silver, gold. Okay, so these are basically what we do is the plating. Okay, the plating operation. Okay, the electroplating operation is being done. Okay, so that it can conduct the electricity or the information or basically the electricity only in a without much resistance, correct? So electricity always try to take the least resistant path, correct? So basically by using gold plating and all, we are actually having the better conductivity, correct? So that's why you can see these kind of terminals being made out of or electroplated, correct? So this is what we generally do for terminals, right? So so we have two components which are used for electrical terminations, basically your terminals as well as your connectors. Okay, further we have protection devices. Okay, so what is used in the automotive, we generally call it as corrugated tubes or corrugated flexible tubes or car tubes. Okay, so basically these are convoluted components, okay, which can are flexible. Okay, that can actually be used for protecting these wires from um, as I was explaining, the dust, the water, or any chemical attack, correct? So it should not uh, burn the actual wires which are inside. So that's why we are actually going to provide these protective equipments, correct? So these are used to protect the harness from thermal as well as physical damages generally, correct? And since you can find these components in different colors, okay, it can also add to the appearance part. And then also it can be used for the identification purpose, correct? So we can use different set of color for the color coding purpose so that it is easily understood, correct? So these are the major things or the usage of protective covering, okay, or protective devices. These are again made out of plastic materials, correct? And then they are resistant to temperature, wear and tear as such, correct? So this is the use of protection devices, correct? Further, we have something called as grommets. We generally call it as sealing grommets. Okay, so these sealing grommets majorly have three main purpose, as you can see in the image, basically for sealing, and further we have protection as well as for vibration absorption. Okay, a sealing edge protection grommet, okay, is what you can see in the image one. Okay, for an example to suggest where this is used is where you can see the wires going from a wet zone to a dry zone. Okay, so the outside of your car to an inside of your car area, okay, the passenger compartment area. So that is basically you can see this sealing edge protection, correct? So this sealing edge protection grommets are found in such areas where the wires goes from a wet zone to a dry zone, correct? So that is about the sealing edge protection. Similarly, you have the edge protection. So you have the moving components, which is going to be a part of your car. You can see your door and other things. So whatever wires are going from your body structure to your door, okay. So for the passage of the wires, we are going to use this kind of edge protection grommets. Okay. So these grommets are going to provide proper protection from the edges and sharp corners. Okay. So that the actual wire doesn't uh, go off with wear and tear. Okay. So that's why we are going to use this kind of edge protection grommets, correct? Further, we have something called as the vibration absorption grommets. Okay, these are basically used in areas where the wires are attached near to more vibrating components like your suspension parts and then wheel area. Okay, so the one which you see here is a grommet which is used near the wheel speed sensor, correct? The wheel speed sensor is what you generally see near your wheel. Okay, so it's basically going to measure the rotation of the wheel, correct? So there you are able to see the sensor along with the wires, and then there is a grommet to make sure that these wires don't vibrate much. Okay, so that's where we are going to find this kind of vibration absorption grommets, correct? So these are again rubber molded parts, okay, which are used for sealing purpose as well as for absorption of vibrations, correct? So these are again what you generally see in an automotive. Okay, so if you had opened a car and then seen, you can see these kind of small rubber grommets on your automotive systems, correct? Now coming forward, you have something called as insulations. Okay, so just like your um, protection devices, okay, this is also used for protection. Okay, so they are again made out of PVC, cotton, or it can be even polymer materials, correct? So here also we can find it in different colors. Okay, so the protection devices like the corrugated tubes, you have to insert the wire inside those tubes, correct? But here these tapes, as you can see, like your cello tapes and other things, okay, these adhesive insulation tapes can be wound over to the wire systems for protection, as well as for aesthetics, as well as for providing the uh, or understanding the notations which you are given for the wire. Okay, so these are the um, uses basically you have for insulations, correct? You can get it with PVC material, what you can generally see in for household application also. Further, you can see this cotton material, okay, cotton PVC materials, okay, or cotton insulations, okay. These are basically used in areas where there is more heat, okay. So to protect your wires from heat, we are going to use this kind of cotton insulation materials, okay. Now coming to some of the studs and clips and components, correct? So these are some of the components which is found as a part of your uh, mountings for your wires. Okay, so the cable straps, if you can see in your household also, you can see basically used for mounting your cables, okay, in a system, correct? So the same thing which you can found in automotive application, okay. So this are simply called as simple cable ties, correct? Further, we have push fit types. Okay, so there will be mounting holes available in your car body structures. So these will be mounted there accordingly, and then you can actually make sure that the wires are passed through those uh, mounting areas. Correct. So these are of majorly two types again: round and anti-rotational. And then in the round type again, we have fir tree as well as anchor type. Okay, the fir tree is basically because of the shape of the mounting to the hole accordingly. Okay, so basically they will be having a mounting in such a way that it can actually be in the shape of a tree. Okay, Christmas tree kind of. That's why it's called as a fir tree clip. Okay, so further we have the anchor fit. Okay, it has the shape of an anchor. Okay, so that's why it's called as an anchor fit. Correct. Similar way, we have other types called as the stud type clip. Okay, so there will be some stud mountings available on your car. There you can mount this kind of clips. Okay, edge clip is where you are having your sheet metal edges. Okay, and there you can actually push these edge clips and then it will attach to that. Okay, the only problem with respect to using these kind of edge clips are basically it actually tends to remove the paint in that particular area where we are trying to mount this edge clip. Okay, so because of this problem that it is going to scrape out the paint from that area, there can be a cause of corrosion in that area. So we try to avoid edge clips as much as possible, but there are some situations where you need to use this kind of edge clips. Okay, so that's where we are going to use this kind of edge clips, which is again a part of your mounting components, correct? Sticky clips, as the name suggests, is basically you will be having a double-sided tape or a sticking mechanism, or it will be having sticky surface, so that that sticky surface can be attached to any body structure, and then you can loop in a simple cable tie through the mountings available on this particular sticky clip, and then you can have the mounting of the wires, correct? So further you have the wire to wire, the simple cable tie only had one loop. Here we can actually loop this wire to one structure and then further loop the set of wires onto this wire. Okay, so that's where the wire to wire connectivity of cable straps can be utilized, correct? So these are basically some of the components which are used for the mounting of these wires. Similar way, you have something called as separator clamps. Okay, the separator clamps are of two types basically. One is the panel mounted, and then another one is the wire to wire. Okay, so the panel mounted are basically where you can mount to the holes just like we looked earlier, or it can be bolted, correct? So these separator clamps are used to make sure that if there are like two sets of uh, lines of wires going parallel, okay, we need to make sure that there is some um, gaps being maintained within these wires, because there are power being transmitted. Okay, so that can lead to impedance. Okay, so that can lead to some problems if it's not being done properly, correct? Okay, so that problem being the impedance or the some data, okay, which might not be transferred properly, correct? So to avoid that, we are going to use this kind of separator clamps. Okay. As a design engineer, these are some of the things which you will be doing, okay, to make sure that, okay, so there is separation between the components, and then trying to understand what mountings are available at that area, and then understanding what type of mounting component can be utilized. Okay, it can be a hole mounted if there is a hole available, or it can be an edge mounted clip if no holes are made available at that area. Okay, or as a design engineer, you are going to suggest whether a hole can be made available in that area to the designer of the body structure, so that you can mount that component over there. So these are some of the things as a design engineer you will be doing. Okay, so the applications, as we mentioned, is basically for clipping and clamping these components onto the wires structures onto your body structure. Correct. Similar way, you have this fuse and relay box, just like you see in your circuit board in your household. Okay, so basically these are again plastic molded parts. Okay, which is actually used for protecting the major systems. Okay, so when there is a surge of electricity or power in the system, okay, so that can actually flow into the major devices. Okay, and then that can actually cause the blow up of those systems. Correct. So to prevent that, we are going to use these kind of fuses. Okay, so these are small materials made out of metal wires. Okay, so that can take up the load. Correct. So there will be fuse boxes which are available in your vehicle. Okay, when you must have taken your vehicle for a service, you must have seen they're going to check this fuse box and then see if everything is in working condition or likewise. Okay, these fuse boxes can be generally placed in your dashboard, inside your dashboard area, lower to your leg area, okay, of the driver. Correct. So it's basically easily accessible by the service person, so that he can check for any damages and then put a new set of fuse, okay, if that is being damaged. Correct. So this is basically used for the protection of your systems, major systems in a vehicle. Correct. Further, we have retention devices. Okay, retention device, again plastic components used for additional protection, additional mounting. Okay, and likewise. Correct. So these mounting clips is basically having an additional protection for your connector. You have secondary locks basically to make sure that the wire doesn't come out very easily. Correct. And then we have something called as back shells, basically in areas where the space is very low, and then if you want to make sure that there is a directional change to be done on the wire systems, then you are going to use this kind of retention devices. Correct. So in tight space area where you want to squeeze the wire tightly, you are going to use this kind of retention devices called back shells. Right. Further, guiding channels are other components you generally see in any car. Okay? So these are basically used for making sure that the wires are properly arranged in the system. Okay, or the bundles are generally properly arranged in a system. Okay, so these are made out of plastic or sometimes metal components also. Okay, so that the wires are guided properly to the right input or output systems. Okay, so that's where we find these kind of guiding channels. These are generally seen in areas like your engine areas, okay, or it can be basically in your dashboard components, okay, so that the wires are being laid out in a structured manner. Okay, so that's what we are where we are going to use this kind of guiding channel components. Correct. Further, other electrical components are like your terminating resistors, diode packs, and controller and fuse boxes. Okay. Basically, to make sure that it's making sure that the harness is being laid down properly. Correct. So each and every component which we have discussed here, okay, are going to play an important role with respect to the wiring harness to be laid down in a vehicle. Correct. So this is how a typical flow of an electrical distribution system in a vehicle looks like. Correct. So there are multiple engineers who are going to work on developing the final output, what we are looking here. So first step is basically understanding about the logical architecture. The logical architecture is going to deal with understanding about what are the different systems and subsystems, which is going to be a part of your vehicle system. Okay. So out of this logical architecture, we are going to develop something called as electrical schematics. Electrical schematics is going to give an idea about what types of connections has to be made. Okay, whether it's a single way connection or it's a two-way connection, likewise. Okay, and then how are the systems being connected, interconnected together. That layout is what you're going to get from an electrical schematics. Correct. So basically, from the designer's perspective, the thing which he is going to look into is something called as physical architecture. Physical architecture gives an idea about the car and then the placement of each and every component, where the light components are, where the dashboard structure is inside the dashboard, where is the connections for your display unit and other things. Okay. And then further here from the back side, you can see your tailgate and other tailgate light and other components, correct? So based out of this physical architecture data, you are going to develop something called as the harness routing, okay, wherein you are going to place the components and then develop the routing with respect to all the body structures, okay, so that the wires are intact in the system, okay. So that's what we generally do with wiring harness, or that's what we understand by packaging, okay. What we are doing in packaging is we are packing the systems properly so that everything is put up in a neat and tight manner, correct? So now after a design engineer develop these, okay, his aim is basically to develop a harness drawing. It's just like any design engineer who actually works on developing drawings. His part will be to make sure that he develops a drawing for your harness which is developed. Okay, so out of the 3D data, whatever he is having, okay, he is actually going to develop a 2D model. Okay, so this 2D model is going to have the data like what is the set of wires being utilized. Okay, what is the wire standards being utilized, okay, what is the length of wire, and then what are the different other components which are going to be a part of those wiring harness components, okay. So individually you can have for different sub components, like your door can have set of wires, your body structure can have set of wires, okay, your engine area can have set of wires. All those combined will lead to a wiring harness assembly, okay. So this is what a design engineer looks into by developing wiring harness for systems and subsystems, further assembling them together, okay, and then further developing a harness drawing which can be utilized for actually understanding how a physical model can be developed, okay. So is what happens in a harness drawings area, okay? So this is how a typical flow happens in an industry, okay. As a design engineer, you look into the uh, physical architecture data, and then from the electrical schematics you actually look forward to developing your 3D routing, and then develop the harness drawings for your final physical model development, correct? So the routing process goes in a, or a packaging process goes in an ordered manner, wherein first we collect the input, basically the understanding of the structure where you want to do the routing, okay. So that's basically the physical architecture. Then we try to understand about the specification of the vehicle, okay, where are the different by specification I don't mean the what is the power and other things, but we are trying to understand about the wet zone, dry zone, what is the engine zone, okay, the thermal areas, basically where is the heat zones, and then also understanding about the sequence of assembly of these components in a vehicle, correct? So we can see whenever you're manufacturing a car, okay, we are assembling it in some order. So now this is very important input for a wiring harness person to develop the wiring harness, correct? So based on that data only, he is going to lay down the wires so that the other systems can be laid down in the order, correct? So now having got these inputs, okay, we are going to look into the analysis part, okay, where we understand about what are the past learnings from the previous manufacturing data, okay, what is the geometry of the vehicle, correct, and then uh, what a resolution has to be done with respect to the previous failures and other things, okay, and then also understanding about how the assembly process has to be, correct. So having been done this, the next stage will be the harness topology. The word topology actually leads with understanding about how the wires has to be split, correct. So here we are actually going to understand about how the proposals from different teams has to be taken for splitting the wire systems, okay, whether it has to be a continuous set of wires from the front to the rear, or whether it has to be split up for different areas, okay. Why this split up is required basically, okay, this split up is going to help us with respect to understanding if there is a service requirement, correct. You can, instead of removing all the wire set, okay, you can actually take up one particular portion, remove it, and then provide a new set of wires, and then you assemble it back, okay. So that way what we are going to have, okay, you are going to make sure that you are not going to spend too much time on developing one set of wires, okay, and then we are going to have a new particular set of work done, okay. So cost involved will be reduced accordingly when we are working on uh, this set of wire development, correct. So having been done with the
Yeah,
harness
Akash.
topology, yeah.
Yeah, Akash, sorry for interruption. So, guys, those who are asking till what time the session would be, so this session is till 6:30. Okay, 6:30 p.m. We'll be wrapping up. Maximum it will go till 6:40 p.m. Okay, and we'll be wrapping up by 6:30, 6:40 p.m. So, I hope a lot of people were asking, so thought of just clarifying that. And if you are having any questions, please drop the questions and we'll take it up at the end. Okay. So Pranay, what is harness? So we have started this session with that only. I don't know, you basically started to attend this session in middle, but we will cover this question at the end if you still have the doubt. Okay. Yeah. Sorry, Akash, for the
Sure.
interruption. Please
No
take it
problem.
over.
Yeah. Thank you, Mehul. So we are dealing with the harness topology part. Okay. So harness topology, as I was telling, is splitting up the wires for the requirement. Further, we have the harness routing concept. Okay. So we are going to develop the first concept for your harness routing, wherein we start developing the 3D model for the placement of the different components and then starting the routing. Okay. So we will be publishing the first set of data. Okay. So now there will be a design review for the first level of concept routing, just like any process. Okay, whenever we're introducing a new process or a new thing, okay, we generally go for a review, correct? So there will be multiple people involved in the review. Okay, so we, with this review process, what we are generally developing is a mock-up, okay, or DMU, digital mock-up. Okay, so all the teams will be involved in this product development. So the product team is going to look into the data whatever we have worked on, correct? So they'll be looking into whether the integration is proper, all the connections are made correctly, or whether these kind of a setup can be manufactured, okay, or that can be easily serviced, correct? Has the purchase team also looked into whether these kind of components which are being utilized in the system can be purchased, okay? Is it easily available in the near market, correct, around markets, okay? And then also the CA team will be involved in understanding about the thermal mapping data and other things, correct? So based on this data, and then further the feasibility of the suppliers and other things to different components, we are actually going to the next stage, wherein you are going to see the finalization, okay? If there is any modification required in the stages where the cross-functional teams are involved, you are actually again going to go back to a harness concept routing stage for making the modifications. And then we are going to go for the design review again. And then further, if it is okay, we'll go for the finalized harness routing, correct? So in the harness routing finalization, we'll be preparing the minutes of meeting. Then we are going to look for developing a template, and then we are going to publish the harness data according, correct? So once the final harness data is being released, okay, you will be actually going for the uh, final harness proto release, correct? So here basically the supplier feasibility and review report will be looked into for the final data to be uh, made available, correct? So this is a proto release of your wiring harness. Okay, after the proto release is done, then the suppliers will work on providing you the components, and then further you will have the proto build. Okay, so the proto build is basically the first stage where you start with the routing with respect to the vehicle to understand whether the packaging is proper, correct, whether the suppliers are okay in producing the components for you, and then also testing with respect to all the electrical systems are working together, and then validating that, correct? So if there is any design stage in this, again you will have to go for a design review again, which is going to be a costly affair. Okay, so in the first stage itself, we need to make sure that everything is checked and double checked properly, so that you actually go back to or in the first stage itself we are having a good product, correct? So this is basically the process flow, okay, the routing uh, flow which happens in an industry. Okay, so from input collection till developing the proto build for your wiring harness systems, correct? So multiple teams will be involved here. Okay, so there will be engineers who develop systems. There will be the different other cross-functional teams who are going to provide you inputs with respect to whether the routing is proper or not. And then you are going to develop the complete 3D routing for the car structure. Okay, so this is also a part of the process where you are actually going to develop a new car. Okay, so for that new car, you will be having the wiring harness also being developed, right? So having being said that, let's try to understand some of the suppliers for the different components which is being utilized for the wiring harness development. The first major area is going to be your connector suppliers. So the connectors are basically used for the termination part. So TE connectivity or Tyco Electronics is one major supplier or player in the market for the connector components. Further, we have this Deutsche connectors. Okay, so Deutsche connectors is already being acquired by Tyco Electronics now. Again, you can see these are one company which was majorly providing connectors for the automotive domain, correct? Further, we have companies like Molex, Amphenol, Aptiv. Delphi, Yazaki, Sumitomo, JST, Furukawa, and Deere. Okay, so some of the companies are available in the Indian market, and then some of the companies are available in the foreign market. Okay, these are some of the active players in the Indian market. If you see for the automotive sector, okay, so if you see Maruti Suzuki, they will be using components from Molex or Aptiv. Okay, and then further other companies like Tata, Mahindra, or any other company who are looking for um, providing these components will be utilizing these companies for developing the wiring harness components and then connector. Okay, so based on companies, the suppliers will change. But again, coming to the service requirement, okay, they are all going to follow some similar standards so that it can be used accordingly. Correct? They can use Tyco connector, and then they can use Molex connector. Is going to have the similar set of specifications or a range of usage. Correct? For example, Tyco is providing a connector which is basically in the range of 20 to 30 degrees Celsius. Molex also will have another connector, but with some variation like 20 to 35, a 5-degree extra it with hand. So similar way, there will be connectors which you can utilize for the usage. Correct. Further, coming to some of the standards of wires. Okay, so as I was mentioning in the beginning, okay, wires are basically used for carrying the current as well as for information. Correct. So there are different standards you can see in wires also. One major standard is the DIN standard. So this standard is basically a German standard which is being utilized. Okay. So similar to DIN standards, we have something called as the JSO standard also, basically which is a Japanese standards. Okay. So the DIN standard and all will also for have the equality with respect to ISO standards for wires utilized in the Indian markets also. Correct. So how do you read the namings basically? Correct. Just like any notations. Okay. Here also we can see the ratings or the namings given accordingly, like FLY 0.5. So by FLY, we generally understand that it's basically an automotive cable with PVC insulation, okay, with a nominal cross section of 0.5. Okay, or the when you cut the wire, you can see a circular section, okay, that's having a nominal cross section of 0.5. Correct. Similar way, we have the FLRY 0.75, basically 0.75, basically the cross section. And then further we have FLYK. As you can see, all the notations are being clearly explained. Correct. You can also have these wires which are made out of alloy components. Correct. So copper alloying, silver alloying. If all those things are being added, you will be having the namings or notations accordingly for better understanding, so that the person can understand what set of wires has to be utilized and then what set of wires he has to buy for those particular application. Correct. So JASO standards also has its own notations, basically like AV, basically vinyl insulated low tension electric cables for automotives. Okay. So AV is basically for automotive application, and then AVS is basically automotive with wall thickness criteria. Correct. And then we have AVSS, AVX, AEX, etc. Correct. So basically based on the uh, thickness of the wires utilized or the power carrying capacity, okay, or the amount of protection which is being provided to it, you will be having the JSO standard wires also basically with different notations. Okay. So the DIN standard wire basically are used for general road going cars. Okay. But JSO standards are mostly preferred in passenger cars along with commercial as well as off-road vehicles. Correct. So basically rugged operation is what we are looking forward to here. Okay. For rugged operations, we are going to use JSO standard wires basically. Okay. Coming to the wire supplies, just like your supplies for your connectors. Okay. Tyco Electronics is again available for wire production. Correct. Similar way, we have one another major market player called Leone. Okay. As well as Yasaki. Phenolics and all you must be knowing, basically used for the household application, which can be again found for automotive application as well. Okay. And then further we have Aptiv, Sumitomo, Polycab, and Molex. Correct. So these are some of the suppliers for the wires in the automotive sector. Correct. Protection devices we looked into already. Okay, basically for the additional protection from the heat, okay, or water ingress, okay, as well as providing some um, thermal and physical damage, okay, wear and tear, and also to improve the appearances. Correct. So the selection of these wires are also important. So the selections are based on the sizes and diameter. Okay. The type of the protection devices. Okay. Based on your requirement. Correct. What is the temperature range of usage of those particular wires, or in what area of usage it's basically, okay, whether the abrasion resistance requirements is there, okay, or if there is a color requirement accordingly, and then further the cost considerations, correct. So based on these parameters, you can select the right set of protective coverings, correct. So for protection suppliers, we again have Tyco Electronics or TE Connectivity. Other companies are like Shemless, Panduit, Yazaki, Leone, and Sumitomo, correct. So many more suppliers are available in the market, but based on area and geography, you can find different other companies also available. But okay, so these are some of the supplies which are readily available in the Indian market, right? Now coming to some of the other standards, what we generally look forward to whenever you are in the wiring harness domain. Okay, so that is basically your IP rating or the ingress protection rating, correct. Any electronic device generally have these standards. Okay, even your mobile phone, okay, or any electronic gadget you are having will generally have this kind of IP ratings. Okay, you must have seen IPX7 and all are some of the ratings which you can see for your mobile phones, and similar thing which can be seen for your headphones, earphones, etc. Correct. So basically, this IP rating is used for providing the standards for protection from dust as well as water. Correct. So it is basically defined from an international standard EN 60529. Okay, or an from a British standard, as well as the corresponding standards in European is basically the IEC 60509 and 1989. Correct. So these are basically used for understanding the level of sealing, okay, which are available for your systems, correct. So how properly packed the system are, okay, for protection. Okay, so basically there are two digits which we generally follow after the IP standard name. Okay, so the first digit after IP generally looks forward to the standards for the dust protection or the dust ingress protection, and then the second digit corresponding to the water ingress protection, correct. So basically the highest rating which is available for the dust ingress protection is 6, where it protects the whole system in an airtight package without any availability of ingress of any dust, correct. Similar way for the water ingress, we have a level of 9. Okay, we mentioned that IP69. So if IP69 is there, then that is the highest standard which we have for protection from dust and water, correct. So sometimes you can see the IPX7 or X6 generally mentioned. Okay, so the X generally means that there is no dust protection available, but only water protection. Okay, so this can be seen for your gadgets in your households, correct. So IP69A is what we generally see for automotive application, which is the highest standard, correct. Again, in automotive application, we are going to use it for a long term, and then your vehicle are going in different areas, okay, in water condition and all. And there are going to be wires which are laid down in those areas accordingly, correct. It can be on the wires can be laid down throughout the vehicle, correct. So there can be wet zones and dry zones available in your vehicle. So in the wet zone, you can see there must be devices which are used with higher protection. That's where you can see the IP69A rating available. Okay, or the components used in that area will be having a rating of IP69, correct. So this is with respect to IP rating. Further, some other areas as a design engineer which we are going to look for is the thermal conditions. Okay, so the thermal protection of your wire systems. Okay, or the thermal management we generally into. Okay? So whenever we are looking into this thermal management, okay, so we generally look into the routing as well as the thermal protection, correct. So how do you get this data? So when you are looking forward to developing the wiring harness, okay, and then you are looking for understanding about the temperature zones, okay, what we generally look forward to is the thermal mapping. Okay, so thermal mapping is where we understand about in a particular area what are the different ranges of temperatures which you have, correct. So when you see an engine, okay, so there can be different zones. Okay, so basically the area where the power is produced, okay, so the cylinder areas is where you are going to have the combustion happening and where the temperature is going to be the highest. Okay, so the temperature can range from 200 degrees Celsius and above, correct. So on that areas also you are actually laying down wires for basically your injectors as well as spark plugs and other things. Okay, so we need to be careful with respect to how the routing is being done on this area, correct. So basically we are going to use uh, high protection devices like cotton tapes as well as nylon and silicon tapes, which will be provided on silicon tubes, sorry, which we are going to use on those particular areas, so that we are actually able to withstand temperatures in excess of 900 degrees Celsius, correct? So the silicon protective coverings and all can actually withstand temperatures in excess of 350 or 330 degrees Celsius and above, correct? So we need to basically understand that we have a thermal management data before we do the routing. So this data can be provided by the engine manufacturer. So from that data, we are actually, as a design engineer, we are going to check and understand whether the routing can be done in a proper manner, and then accordingly, we are going to use the different systems to route it in that particular engine area, correct? So this is one thing as a design engineer which we are going to look into, correct? So no further, basically you can look forward to understanding about routing. As a design engineer, you can work on areas like engine area, where you are going to work on routing for this particular area. You can see in the engine area, you can have different sensors like your exhaust gas recirculation sensor, the pressure sensors, the temperature sensors, everything available. So for these components in an engine, you are going to use different uh, set of wire components, and then for this you are actually going to use some protective equipments also. Okay, so those standards of wires, connectors, everything will be what you're going to learn accordingly, so that you understand, okay, whenever you're given a new engines setup, okay, how to work on developing the routing for that particular area, correct? Similar way, you can actually work on new sets of projects on working on the body structures. You can have the side door panel, you have your uh, back door panels, okay, or the front, the complete passenger area where you have the infotainment and other things. Okay. So all those things has to be separately built and then further interconnected together, okay, so that you have the complete setup of wiring harness. Okay, as a design engineer, your uh, main work will be to make sure that you understand the requirements which has been brought to you, and then you actually work on developing the routing, correct? So having been said that, okay, basically there are tools which will be required for you to help in developing this 3D routing. Okay, so CATIA or the Salt Systems CATIA is one major software, okay, which is available in the industry, which is used by top OEMs and suppliers in the market for developing these uh, wiring harness routings, correct? So they have their own different modules for electrical applications, for equipments and systems. And then there is a set of workbenches which are available in CATIA, like the electrical part design, electrical harness assembly, harness installation, and factory, correct? So electrical part design will be majorly used for developing the electrical parts, okay? And then the electrical harness assembly for developing the routings, and then installation of the system. And then further, you have the harness flattening, basically for making sure that you get a 2D routing out of the 3D, so that that data can be utilized for developing your drawing sheets, for developing your finally developing your physical model, correct? So CATIA is one such an application, okay, a 3D modeling software, okay, basically used for wiring harness 3D modeling also, correct? Similar way like CATIA, you have softwares like NXCAD, okay, which can be utilized for developing this kind of routing. Okay, so these are some of the or two major softwares which you can find in the automotive industry as such, correct? So it has some sets of rules and standards which you are going to follow. Okay, accordingly you are going to develop the routing, correct? So as a design engineer, okay, your main understanding is to make sure that you understand the rules and regulations which has been explained. It can be with respect to the space availability, okay, so to make sure that if you are routing in a near an engine area, we need to make sure that, that much of gaps is being maintained between structures, correct? Or if that is not the case, then you need to make sure that additional protection to be provided with respect to the wiring systems, okay? And then also basically understanding about the other standards of setups which you need to follow, correct? It can be the wire standards to be utilized, or it can be the protection standards you need to follow accordingly, correct? So having been done that, then finally it is your idea of how to route with in the system, okay, so that it will be helpful for you in developing the complete wiring system, so that the physical model can be developed, correct? So there's one area design engineer can find job opportunities in the automotive market, correct? So having been said that, so I will wind up the session here. Okay. So I hope everyone was clear with respect to the basic understanding about what is a wiring harness, what are the components which forms a part of your wiring harness, correct? And then what are the different standards, the basic understanding of the standards you should have for basically developing the wiring harness in the system.